Okay, so this is the beginning of the PowerPoint. There's the videos. Okay, so most common ideas of atom shape are these two, that electrons hang out in these nice pretty rings, and that's the only place there are. But the real model of how electrons work and move are, it's called the quantum mechanical model. I'm going to put up all this stuff, but the gist of all these things is that Erwin Schrödinger came up with them, and all it is that electrons don't live in specific rings, they live in these shapes. One of them is a circle. So the next few slides are describing the shapes of his model. Don't worry about electron configuration. So where do electrons are located? It's like three categories. The first is they're in an energy level, and then each energy level has sublevels, and then in each sublevel there's an orbital. So here, the next, I'll just go with it. Here we go. So the sublevels, S's are circle or spheres, P's are like figure eights. The real pictures are coming up in a second. D's are kind of, I call them clovers, and F is, well, there's six. 1, 2, 3, 1, 2, 3, 5. There's 6 lobes. So this shape is really, this shouldn't say number. It really should say orientations. So orientations of orbitals. Entations. So the whole idea of this whole PowerPoint is electrons aren't in pretty rings. They're in these different shapes. So here's the shapes. These are the S's. So there's only one S. So it's just a circle, sphere. There are 3 P's. And all this is showing that the P orbital, it's this like double circle, but it's lying on 3 planes. So straight up and down. And then like that's all these pictures are. It's the 3 planes, X, Y, and Z. X, Y, and Z. D orbitals, it's that clover shape and laying horizontally up and down. Like they're just 5 orientations, and this is the weird one. It's the 3 with a little donut around it. F, what I'm talking about, the flower, like look at, there's 1, 2, 3, 4, 5, 6. Oh, there's 8 lobes, but 1, 2, 3, 4, 5, 6. So there's 6 here, but one of them has 8, but like 6, 6, 6, 6. I can't really tell because but whatever. They're, the F's. There's 1, 2, 3, 4, 5, 6, 7 of them. 5 D's. 1, 2, 3, 4, 5, 3, 1. That's where those numbers came from the previous slide. So energy levels. This is which of these orbitals. Where's the thing? Which of these orbitals are in what energy level? So energy level 1 only has an S. Energy level 2 has an S and has S and P. 1 S, that 1 and 3 P. So don't worry about the numbers in front. Energy level 3 is SPD, 4 SPDF, 5, 6, and 7. They all have SPDF. 7 is it's the bottom row of the periodic table. Now all of this is described in let me end this show on this whiteboard that I have. Okay, so this is a chart that shows like the order that the electrons fill. It just lines up the orbitals, horizontally and vertically. So like each of these circles is one of those orbitals. They just did circles instead of well, technically that would be this would be a circle, this would be a circle, that one would be one of the lobes going that way, and then like that way. Like they just did circles to simplify the you don't have to do all 5 lobes here and all 6 there. Like I probably should keep that, but whatever. This is just the order that the electrons fill. And again, so like energy levels, the numbers in front are the energy levels, but how do they fill? 1S fills first, then 2S, then 2P, then 3S. And the whole point of this is to show, okay, So this is how an electron really looks. If you were to throw all those orbital shapes in one big picture, it's going to start getting confusing. So black will be 1s. So 1s is this is, you know, let's put some other color in, whatever. Okay, so 1s, pretend the nucleus is here. There's a nucleus there right in the middle. This is 1s. Then 2s is the circle shape, and it's just a little bit bigger. And there's 2 electrons here, 2 electrons here. Then 2p goes, all right, here's 2p. So 2p is just a little, all the p's are just a little bit bigger than like 1s, 2s, 2p. Oh, 2p. And so then like, all right, here's the 3p shapes. And look how crazy this gets. And then there's 3s, and then 3s is just a little bit bigger. And then 3p, so wait, let's go, this is 3s, 3p is gonna, whoa, what's that? 3p is gonna be this rainbow. Okay, so then here's the p's, here's the 3p's, and they're just slightly bigger. And okay, so that looks crazy. We'll stop at 3p. 4s would be even bigger, but this color looks the same, right? 4s, 2s was red. So, okay. Like, and in each of these little shapes, each of those orientations, there's only 2 electrons. So really an electron could be, let's see, an electron can be, instead of in rings, except for the s's, like an electron could be here, or then it could be here. Or it could be somewhere in there. Like, it's not beautiful, pretty shells. Like, that's really all that's saying. Okay, back to the PowerPoint. We are here. Okay, this one from current slide. Okay, so how do electrons move between levels? This is the part of the book that is super duper important, and why we're doing all this. Like, I have a demo video to show you on the next slide. So how do electrons move? They're here or here. And when the book said when they gain energy, so like if this guy were to gain some energy, it would jump out here. Jump. And the funny thing about quantum mechanical model is that, and so when it gains energy, it just moves out. But when it releases energy, this is the cool part. This is what the demo talks about. So now there's this, let's see, there's the electron out here now. Not in here anymore. He's out here. When they like lose that energy and fall back down, this is the cool part. So when he loses some energy and moves back down here, that energy is released as light. The name of the energy, that step in energy between those two places, is called a quantum. But the light that is released is called a photon. So the energy it releases that is called a quantum. The light releases a light. It's photon light. Okay, and so then here, let me pause. Okay, so I wanted to add on to this photon idea. Well, I forgot what it was. Hold on. Okay, so I remembered. A photon, the cool, actually neat thing about a photon is it is only a photon. It's only one, where'd my pen go? A photon is only one specific, specific color. So, like, let me add another like a ring. If there were another ring in here, I pick a different color pen. So let's say if there were another ring out here, and an electron went from here to here, let's say it would release light in red. Like that photon would be red. And then this electron went from here way out to here. And then when it would fall back down to here, that photon would be, I don't know, blue. So, like, the further an electron moves when it falls, the different colors are emitted. And that right there is what our demo is about. So I'm going to pause it and go to the... Okay, so this video is called flame test. So each of these colors is a different chemical, and I'll probably come in here. Let me just pause it for a second because at one point I come in. Okay, so that's actually a pretty good picture. Well, no, let's go back a little bit. Which one has? Well, okay. All right. So, here's all the if you can tell, the orange is impurities, but the colors in there are like that photon idea of light. These are all different metals. This is calcium, copper, lithium, and lithium is this really pretty. Calcium's kind of an orange color. Copper is this green. Lithium is this beautiful pinky color right here. This is supposed to be potassium. Potassium is supposed to be a pink lavendery color. It's really hard to see. It might be this right in here. Sodium is orange, and this is strontium. So I put them in alphabetical order, and I'll put the slide up that says which each chemical is. We'll play it for a couple more seconds. Oh yeah, there's sodium. So yeah, I'm gonna pause and go back to my PowerPoint. So no, I'm not gonna go back to the PowerPoint here. Pause. Okay, so each of the colors of the light that those metals were burning were like that. So copper was green, really. So one of these should have been a green light, and and strontium is red. Like each of those metals had its own color because of this photon idea that only one color of light is emitted when they fall back down. So okay, there we go. Okay, so I'm posting the whole video of the flame test on there so you can do a color. Look at the colors, and I probably went through and said what the chemicals were, but I have an unknown where I put 2 metals in. So 2 of those flame colors will be in the unknown. And your whole assignment is to tell me why. Tell me what 2 metals do you think are in there. So, yeah. And so this is one little explanation. Stay tuned for another video onto how electrons really move. Well, just one more mini explanation as to how electrons really move.